Hello class, welcome to this introductory tutorial on how to program the PLCs that we have at the Control Lab. In the example for today, the idea is for you to learn how to create a new project and connect to the PLC. Basically, we will use these buttons to control the LEDs, and we will use the potentiometer to command voltage and use analog inputs and analog outputs. After that, we will also see how to create cyclic events at a lower sampling rate to toggle one of the LEDs. And finally, we will work with the human-machine interface also to control LEDs and to show real-time data. Right, so let's begin creating a new project at TIA portal. We'll click here, create a new project. You can call this project whatever you want. Example, project 1. I'm gonna create this, wait for the program to respond, and the first thing we have to do is to choose a PLC for our project. So we can go here, configure device, add a new device, and we need to choose our controller. So for the class we're using at the beginning we're using the S7-1200, and here we need to check in the PLC which is the model we are using. So we are using the 1215C DC-DC 1215C DC-DC relay. I think it is 1HG40. Yeah, this one is our PLC. So here it's important for this tutorial, just keep everything without protection, so you can make changes and we can modify your code after you leave the lab. So let's click next. This one can be secure communication, that's fine. We will use full access, no protection, and that's all, finish. So now the project has been created. You can always go back to the first view using this icon right here. You can come back to portal view, and here you can go back again to the project view. As you can see, this is the PLC we are using. Nevertheless, if you see your real hardware, we have a few additional input-output boards that we can add using this bar right here. So for example, we have here the 1PH32. This is it. You can drag it to your screen. This is for digital inputs and digital outputs. And we also have the 4HB320X. This one is for analog inputs. Okay. Oops. So with this, we already have told the system TI portal, which are all the hardware that we have in our setup. Right, so before we keep moving forward, we need to check that the IP of our PLC is in the same network as the IP of our computer. So if you press Ctrl and scroll, you can zoom this view, and you can double click in the Ethernet connector of the PLC. Let's move this up. As you can see here in the Ethernet address, this PLC has this address, which is the default address for the PLCs, 192.168.0.1. So we need to check in our computer and make sure that these three numbers are the same for our computer. This one must be different. So you can check that in control panel, network and internet, network and sharing center, and I think this is the Ethernet connected to the PLC. Yeah. So you can press here, properties, TCP IPv4, and you can see these are the same numbers that we have in the PLC. Oh, it's not the same, but that's fine. Yeah, these three are important, and here I'm using 17. Okay, so after we check that, we should be able to see the PLC in our Profinet network. So for example, we can go here to online, extended go online, and as you can see, the system is recognizing this PLC. Go online. Okay, so in this interface, you need to select the Ethernet adapter. In my computer, this is my Ethernet adapter. And to search for all the available devices, you need to click this option right here, show all compatible devices and start search. This might take a few seconds. And there we go. As you can see, I'm able to see the PLC that is connected to the network. If you have more than one PLCs, they will appear in this list, and by selecting this one, you can flash the LED in the hardware. Well, you cannot see it, but it's flashing right now, and yeah, so we can select this and go online. To say that we trust this device. Okay, connect. Perfect. Yeah, if you are able to see this orange bar right here, that means that the connection was successful. So yeah, with that we can keep continuing with the tutorial. Right, so if you see the left side of the screen right here, you can see the individual files and everything related to this PLC in this project of program blocks. If you go here, you can see like these warning signs that we have right here. This is telling us that the program that we have in this laptop is not the same that the program that is loaded to the PLC. So as you can see now, my program is blank, and what I'm going to do is to upload this blank program to the PLC. So to do this, we need to press this down arrow, which is download to device, and we should be able to load the blank code to the PLC. Okay, so continue without synchronization. We'll have to stop the CPU, that's fine. Now it's loading. And now we can choose if we want to turn on or turn off the PLC. So I'll just say turn it on, to turn on the CPU. Perfect. As you can see now, everything is green. That means our laptop is synchronized with the PLC. Right, so before starting to program the logic that we will use for this example, we need to start defining the inputs and outputs that are wired to our PLC. And we can define each one of those using this folder here, PLC tags. You can go here, show all tags, and here you can enter one by one which are the inputs and outputs, or even like the memory variables that you want to create for your algorithms in this table. So what I'm going to do now is I'm going to paste the LEDs, which I already have in a different file. So I'm just going to click paste. Oh, that didn't work. Maybe here, paste. That's it. So as you can see, these are the 8 LEDs that we have in our system. And something important to note here is that for the address, we are using this letter Q. Q is used for digital outputs. So as you can see in the setup, the LED1 is connected to the first output, LED2 to the second one, and so on until we reach the final LED. Now we are going to do the same process for the buttons that are in our PLC trainer. So you can enter this one by one, but I'm just going to paste them from a different file. And yeah, once again, here it's important to realize that the address that we are using starts with an I. This is because the buttons are wired as digital inputs to our system, and this is just the label that you can see in the real setup. Finally, we're gonna input here the switches that we're using, and we have two switches, SS1 and SS2, and again these are digital inputs that are wired into these terminals 3 and 7. So as you can see, all of these are Boolean variables, so they can only take values of 0 and 1, or true or false. Okay, so now we're going to start programming the first inputs and outputs, digital inputs and digital outputs of our system using the ladder programming framework, which is the one I'm showing right here. But just before that, this is the main main program sweep or cycle of the PLC. This will be basically like a while loop that will execute at all times. To configure the sampling time of this while loop, we have to go to the PLC configuration. So that's right here. No, sorry, network and devices. If we go to our PLC again, and we double click it, or we go to the properties, we should be able to see the execution time in here. So let me, yeah, in cycle. So as you can see, by default, the PLC is going to be running this main program, which is here in program blocks, the main program, every 150 milliseconds. So with that said, let's begin to create our first routine of controlling one LED using a button. So what we're going to do is to control LED1 using PV1. Okay, turn on LED1 if we press PV1. Okay, so we are going to add here this block here, and this is going to be our button, PV1. As you can see, the address that is using is the one that we assigned before in the PLC table, in the tag table. So you can see PV1 is related to this address. So in that way, by defining this, we can work directly with the tags instead of using the address register. And we want to assign the value of this button to the LED1. This is an assignment block, and we're going to assign this to the first light, which is this one. Okay, so what does this mean? This is with this diagram we are specifying what is the connection that we want to do with the PLC logic. So this is called the power rail, and this is a normally open contact, and this is an assignment. So basically here we are saying that every time we push PV1, we make this value 1. This input is going to be 1 if we push the button. Then the signal, the voltage that is here in the power rail, will go through and will power on this digital output. It will change this memory, and this memory will change the output value at the end of the loop. Okay, so we have to we can compile this and upload it to the PLC using these two buttons. This is for compiling, and this is to programming the PLC. And we just need to wait. Load. Okay, so the system is programmed, the PLC is running. As you can see here, the CPU is running. And we can test this by clicking this button here, which is monitoring on and off. So what's telling us now is that the signal is going through the system. That means that in the way that this bottom is wired, it is normally connected. So now what I'm going to do is I'm going to press the button. I'm pressing the button right now. As you can see, this disconnected the signal, and for that reason the LED is off. Right, so our bottom is normally connected. So what we have to do is that instead of using normally open contact, we need to use a normally closed contact. And we can do this. We need to use this one. So PV1, and I'm gonna delete this one. So using normally open or normally closed will depend on how you wire the system. In this case, this bottom is wired as a normally connected, normally closed contact. So I'm gonna load the program again, overwrite, it's loading, right, it's loaded. So as you can see now we are online, the system is running, and the signal is not going through because I'm not pressing the button. I'm gonna press the button now, and the signal goes through, and the LED it's turned on. Okay, so if you want to add more actions to the same button, what you can do is, well, you can create a new network, but also you can start adding branches to the existing network. So for example, I'm gonna click here in between after the button, and you can use this here to open a new branch. So for example, every time we press this button, I want to turn on L1, but also I want to turn on L5. And you can do that by including this new output here. So L5, and we can download that into the PLC. And now every time I press the button, I'm gonna turn on both LEDs. Okay guys, so you have learned how to control the lights using digital inputs, the buttons. So it's up to you now to keep doing the following examples with button PV4, PV2 and PV5. Now we're gonna create a new step to read an analog input, which in practice will be a sensor measurement. This can be, for example, the water level in the example we show in the first class for controlling the level in the water tanks. It can be a temperature measurement, it can be a speed. It will depend on your system and your type of sensor. And our job in this network will be to read this value from the memory registers and normalize its value between 0 to 1. Before doing this, I want to show you something. If you go to your PLC right here, as we did before, you will see that all the tags that we created before will appear in this figure right here. So yeah, you will see the relationship between tags and digital inputs and outputs right here. You can change it if you need to. If you double click the PLC to see the properties, we want to see which memory registers are assigned to the digital inputs. So as you can see, these are the digital inputs. These are, sorry, analog inputs, my bad. These are the analog inputs. We have 2 channels in this PLC right here, and channel 0 is assigned to this memory address. So what I'm gonna do now is I'm gonna create a tag for this analog input. So we can create a tag, for example, analog input 1. This will be an integer, and the memory will be as the IW, and the value is 64. Perfect. So now this tag is pointing to the memory direction that is connected to one of the sensors, right? So we go back here, and we're gonna use this block right here. This is an empty box. Empty box means that you can call to any function that is available in your PLC. There is a bunch of functions and instructions that you can find here in instructions. So for example, these are for bit operations. You have timers, comparators. There's a lot of things here. You have PID controllers, communication. What we want to do now at the moment is just normalizing the measurement to 0 to 1. So this will be enabled at all times because the power rail is directly connected to enable. The minimum value that an analog input can take in the ADC is 0. The maximum value that can take it is 27648. Sorry, this is maximum value. And perfect, this is the memory register that we want to read. What we're gonna do as well is that we want to create an internal memory variable to assign the output. So for example, I'm gonna call this normalized analog input 1, and I have an error. Yes, because this tag does not exist. So what I can do is go to tags again, add new, I'm gonna create it, and this won't be an integer. This will be a float number between 0 and 1, but I want to have decimals, so the type of variable that we are looking here is a real variable. And real, and as you can see, is complaining here because this is an input. This is an internal variable, so it shouldn't be an I, and also this is not integer. But the TIA portal will help us here. Okay, so for inputs we use I, for outputs we use Q, and for internal variables we use M. And for real variables we need a T. But as you can see, I have no choice, so only the correct choice. Press OK, and that's it. We have a tag that is pointed to the memory, to this memory right here. So I'm gonna copy this, I'm gonna go back to the main, and now the error should be cleared. Perfect. Let's see if we can compile. Still have an error. Let's see if we can program. MD66, maybe 66 doesn't exist. Let's try with MD0. MD0. Oh, this is the error. I didn't say that I wanted to convert this variable from integer to a real variable. So I think this should fix the error. Sorry for that, guys. Oh, there we go. Now we can load the program. take some time. Okay, perfect. As you can see now, well, I chose this channel 0 in particular, because this one is wired to the first potentiometer in the system, the one that says potentiometer number 1. So if I move the potentiometer to 0, you can see I'm reading 0. If I move it to the maximum value, you will see this value becomes close to this one right here, but the output is normalized between 0 and 1, and that's what we wanted. So this is working so far. Right, so now what we are going to do is that we are going to pass this measurement to an analog output in order to read voltage in the voltage meter that we have in the device. So here is going to be an analog output. So we want to send an analog signal to the VDC meter 1. So for example, in practice, in the future, when you control the tanks, you will have to use this, for example, to send a voltage command to the pump in order to regulate how much water do you want to, to push inside the tanks, or this can be a command for a motor, any type of analog signal for commanding an actuator. What we are going to do here is the opposite block that we did here. So this was to normalize between the minimum and maximum ADC analog to digital converter reading to 0 to 1. Now we want to scale it back. So I'm gonna put this block right here. Again, this is gonna be enabled. Sorry, this one here, this is gonna be, oh, okay, so now we want to scale X. This is going to be enabled at all time because the enable is connected directly to the power rail. The minimum value we know is going to be 0. The maximum, the value of the signal will be this one, norm analog input 1, norm analog input 1, and the maximum value we know is 1. It's 1. No, actually I'm wrong. This will be the maximum value at the output, and this will be the minimum value at the output. So this one should be again 27648. Okay, and we need to create. Again, we want to make this an integer. We don't want to do the same mistake again, and we want to create a variable here to command the output. Okay, so to do that, we need to go to the PLC once again. Devices, this PLC right here, double click to see the properties. And now we're gonna use the analog output. QW64, QW66. So we can use these registers. Unfortunately, these are not the ones connected to the VDC meter. Actually, these are the ones connected. I think these are the ones. Yes. So this extension is just being used for analog outputs. And yet the channel 0, which is QW112, it is the one connected to the VDC meter number 1. So we're gonna use this one. So let's go to all tags. Let's create a tag to relate this tag to this output. The tag will be analog output 1, for example. This will be an integer. We have this arrow right here, and we saw this is going to be an output, so we use QW because it is an integer, and as we saw before, the address is 1112. This is the address that we saw in the extension, right? 112. 112, perfect. Okay, let's go back to to the main, analog output 1, okay, and let's load this program. Load. Perfect. So now the system is running, and as you can see again, because I have monitoring turned on, if I move the potentiometer, you will see a different value at this output. If you examine your real system, you will see that PDC meter number 1 is changing regarding the potentiometer position, and that's what we wanted. Right guys, so now what we're going to do is that we are going to create a toggle for LED 4, and we will do that toggle every 1 second. We will use code, structured text, to program that toggle. It's very simple code, as you will see. So let's move on. Instead of working in the main, I'm gonna add a new block to show you how you can introduce structured text functions into your program. So I'm gonna start with a function. This function will be called, well, toggle. This is ladder. This is what we have been using. This is to use block diagrams. We're not covering this today. And this is a structured text. So we're gonna keep that one. And this is our function editor. So if your function takes inputs, you can create these inputs here. Same for the outputs. But in our case, for today, I'm just gonna copy paste this. What we want to do is just to toggle the LED number 4. So every time we execute this function, we will check if the light 4 is enabled, then we're gonna turn it off. And on the contrary, if the light is turned off, then we're just gonna turn it on. Okay. We declare the function, but we are not calling it in the main cycle or any cycle. So we are going to create a new cycle to call this function every 1 second. So we can add a new block, and we can create an organization block, and there's a bunch of functions that you can select right here, but we are going to do a cyclic interrupt, and I want to do this interrupt every 1 second. So that's 1000 milliseconds. Okay. And I'm going to program this in ladder. So I'll be combining these two programming frameworks, right? Let's create this. So this is our cyclic interrupt. And what I'm going to do here, so this similar, you remember main? The main is running every 150 milliseconds. This will be running, cyclic interrupt will be running every 1 second. And what we are going to do is we're going to do empty box, and we will use our toggle function. Toggle right here. And as you can see, this is our toggle function, which is enabled at all times. If you want to control this toggle with a switch, for example, well, we can simply do that because using ladder. We already declared the switch as SS1, for example. Oh, sorry. So now every time SS1 is closed, then our function will be enabled, which means that our system, the light, will toggle every 1 second. So let's compile this. Stop modus, no action. Oh, we'll have to stop the CPU to load this code. That's fine. And now it's going to ask if we want to start them again. Let's start it again. Perfect. The code is loaded. Alrighty, so just as a checkpoint, guys, so far we have programmed these 4 buttons to turn on LEDs. These have not code. We programmed the analog input connected to this potentiometer we are reading this measurement and then using the measurement to command the analog output, which is connected to PDC meter 1. And as you can see here now, like if we change this value, we'll change the voltage for the input and consequently the voltage for the output. Finally, if we enable switch 1, we will enable our function for the toggle for this light every 1 second, and we can test this just by switching this. And there we go. We have a light that is changing every 1 second. Okay guys, so let's move to the second part of this tutorial, which will be using the human-machine interface. To do that, first we're gonna stop the CPU of the PLC. We are going to go offline and we're gonna add a new device to the project. In this case, instead of using a controller, we'll use an HMI. The one we have is a Cymatic Basic 7 inches basic, and the second model. Okay. Okay, so for the connection, we want to connect the HMI to the first PLC using Profinet. We're gonna leave everything default, maybe change the background color to white. We won't change the lamps, we won't create more screens yet, we're gonna do that manually later, and we won't add more buttons. So finish. And this is our HMI. So as you can see now, we have two devices, the PLC and the HMI, and we should be able to see both devices right here. So as you can see, we have this is HMI, the PLC, and the Ethernet ports are connected through Profinet. In order to be successful with this connection, you need to stop the CPU of the PLC as we did in the beginning of the video. Please don't forget to do that. Also, something that you need to keep in mind. Similarly, as we configure the IP of the PLC, we need to do the same for the HMI. So if you go to the Profinet interface, the Ethernet address, as you can see, in these three numbers, this HMI is in the same network as the PLC and the same network as my PC. This is the device number 2, the PLC is the device number 1, and my PC is number 17. If you are not able to connect them, it is likely that either your CPU for the PLC is running or that you are not in the same network. And you should be able to create this connection. If it's not here, you should be able to create this connection just by drag this point to this point. Maybe we can do this here. Okay, let's delete the connection. And you should be able to click here and create the connection right here. Yeah, so now both devices are connected. Okay, so to work in the HMI, we need to go here, select the HMI, and we can see the screens. At the moment, we just have the initial screen, which is the root screen. Let's try to upload this blank file to the HMI. So let's go download to device, the interface. This is my Ethernet adapter. Let's search for all the devices. My computer is suffering with the video recording and with TIA portal. Start search. Alright, there we go. HMI number 1. Let's load. Ready for loading. Compiling. This takes a little bit longer than programming the PLC, but because we don't have anything, it should be okay. Anything in the model. There we go. Completed, 0 errors, 0 warnings. And well, you cannot see it, but at the moment the HMI is showing this white screen right here. Okay, so let's start creating buttons and switches for our HMI. The first thing we have to do is to register PLC tags that are going to relate to these switches and buttons in the HMI. So for example, we will create a variable which is going to be called screen, just to relate which screen are we showing in the HMI to know that in the PLC side. This will be an integer. Okay, and also let's create HMI switch number 1. This will be a boolean. We need to fix this. So boolean has to be M. Okay. Oh, and this one as well has to be M because it's not an input or an output. It's internal memory variable. Okay. Oh, let's compile this. Okay. For the HMI, we have to do the same, but create the respective tags here. So again, we will have one tag that is going to be called screen. This will be an unsigned integer. We're gonna link it to the PLC, establishing the connection and choosing the tag for the PLC tag screen. I'm gonna use the same name for both. And let's link the HMI switch 1. This one will be a boolean. And this one in the PLC is called the same, HMI switch 1. Okay. The first thing we have to do is that we have to go to screen management, template, and this part is related to the top side of the HMI. At the moment, I just want you to select this input field. We're gonna relate this to the tag screen. So let's link this to screen. When we click this input, I want to display the text list, the screen names. At the moment, we just have one screen, so we're just gonna leave it this way. But importantly, here in events, I want you to delete all the default events, which you can do by going through each one of these windows and pressing this X right here. So delete all the the events because we will program them later. Okay, let's move to root screen. So we are in the root screen. I changed this text and let's control one of the lights using a button. So for example, let's control L3 control. Okay, I'm gonna make this a bit larger. Oh, sorry, I'm gonna move it. Okay, and here in the right side, you can drag and drop the elements to edit your HMI. So at the moment, we're just gonna use a switch. So I'm gonna drag this switch. You can change the side of the switch. You can align these two elements by selecting both. And there we go, alignment. Center horizontally, okay. And if you go to the properties of this switch, properties here, we can assign a tag to it. So this is going to be HMI switch 1. We're going to link it to the PLC HMI switch 1. This is already done based on what we did in the table. And here in these different windows, you can change the design of this button to make it look better. So for example, when it's on, I want it to be green. When it is off, I want it to be red. For the text, let's make it white. Okay, let's try to load this code to the HMI. Load. Perfect. So now what we've done is basically we just told the system and the PLC that every time we click this PLC tag will change from 0 to 1. So when it's on, it's going to be 1. When it's off, it's going to be 0. And now we can program the logic to do something with this tag. So if we go to PLC and to the main, I've already done this. So this is the HMI switch. Every time the HMI switch is 1, this will pass and we will turn on L3. So let's load this logic, and we should be ready to, it's already loaded, we should be ready to test our HMI. Finished. Okay, so monitoring. Right, so the moment the switch in the HMI is off, I'm gonna click it. And I click it, and you can see that the state changed. And this is the HMI, so now you can see the LED 3 is turned on. If I click this, the light turned off. Right, so let's create 2 more buttons for our HMI to control the LED number L7, okay, L7. So we'll do the same thing, same process. Tags, this one will be called start HMI start button. It's also going to be a boolean HMI stop button, boolean as well. And then we go to HMI tags, HMI start button, HMI stop button. Both are boolean. We're gonna link them. Start. It's gonna be stop. Perfect. And we're gonna edit the root screen. So for the button, we're gonna use this element right here. We're gonna move it here. You can make it bigger as well. For example, we can change this to start. It's gonna be our start button. And we can go to properties. So as you can see, this is different to the switch. There is no direct tag related to this button. And what we must do is to edit the events related to this button. So for example, event, every time we press the button, we will include a function. For example, edit bits, we're gonna set 1 bit. So set 1 bit. And now we can link the tag. So this is gonna be the start button. Perfect. So every time we press, we will make this tag, we will set to 1 the value related to this tag. And every time we release this button, because this one we set it to 1, and at some point we want to make it 0 again, so every time we release, we can, for example, reset. As you can see, sets a bool type tag to 0, to false, and we're gonna use the same tag. Okay, so but if we keep it pressed, the tag will be 1. If we release, it's gonna be 0. Okay, and also we can edit the color, for example. We'll do that later. So let's move to the second button. We can copy this one, and this one is gonna be the stop. I'm gonna make them bigger. Just to make it easy for me to press it in the screen. This is gonna be stop. And here, when we press, we're gonna change, make one this flag, this tag, and when we release, we're gonna make 0 this tag. Perfect. And now we can program the logic related to these two buttons. So we can go to main once again, network 8 HMI. This is gonna be a latch L7 with 2 buttons. And what we can do, for example, is that when start HMI start is 1, we are going to set L7 and let's open a new branch. When HMI stop is equal to 1, we are going to reset L7. So as you can see, before we were using the assignment but without set and reset. The difference of using this is that if you make this equal to 1, this will make the output will be 1, but it will stay that way until we have the reset. So we're going to press the button. This is going to be 1. After we release, it's going to be 0. Nevertheless, this will stay on until we press the second button. Okay, let's build this. Load. And now we need to upload the code to the HMI. Remember, you need to upload both. HMI is ready for loading. Still compiling. Okay, now it's ready. So I'm gonna press start. As you can see, if I keep it pressed, it's gonna be on, but if I release, well, you cannot see, but the light is still on, and if I press stop, it's gonna be reset. Okay guys, so this is what I was saying. If I press start, it's gonna be turned on, and you see I'm not pressing anymore, but the light's still on. And if I press stop, the light will be turned off. Okay, let's add an animation to our buttons to make them change color when we press start or stop buttons. So we can do this going to properties. Here we will go to animation, and we can add a new animation, and it's going to be an appearance animation. We can look for a tag here. If you press the 3 dots, we can refer to the PLC tags. So for example, we are using these buttons to control L7, right? So if we're going to read the value of this LED in order to fix the color of each one of the buttons. So let's click in L7. Its L7 is 0. Then I want to make this green, so I know if I press it, it's going to turn on. So let's make this one green. And if it is 1, let's just keep it gray. And let's do the same for the stop button. So animation, add new animation, appearance, L7, new rule. So now when the value of L7 is 1, I want the stop button to be red, so I know I can press it. So let's make it red. And when it's 0, let's just leave it gray. Okay, let's load this. Load. Okay, so as you can see now, the LED is off, but the start button is green. If I press it, it'll go to gray, stop button will be red, and the light's on. If I press the stop button, then it'll turn off and the start is green again. Right, so what we're going to do now is that we will create a second screen. So, well, I already created, but we can do is press here, add new screen. I'm gonna call this a screen plot. By editing the properties, we can change the color to make the background white, and that way it's consistent with the first screen. And the first thing we need to do is to create a button to go from one screen to the other. So I'm gonna drag and drop here one button. I'm gonna make this bigger. This one will say go to plot, and I'm gonna edit the events. So every time we press this button, now instead of working with the bits, we're gonna do a screen function, and the one we want is activate screen. So the screen name is going to be plot. So every time we press this button, we will make the plot screen active. And the same way, we're gonna copy this, go to plot, we're gonna paste this, and this will be home. I'm gonna make this smaller. Right, and for this one, the event, if I press it, we need to go to the root screen. Root screen, perfect. Okay, so for this one, we will add a real-time plot for the measurement. Okay, so I'm gonna drag and drop this variable here, this trend element. I'm gonna make this bigger, and we can edit this to make it look better, right? So for example, appearance, axis color, let's make the axis black. Style, line and area, that's fine. Grid line, let's remove the grid. Do we want ruler? No, we don't want ruler. Okay, border, that's fine. Table, this table right here, let's remove it. This is the left axis, it'll be normalized, so let's go minus 0.1 to 1.1, increments of 0.05, and the right value axis, let's remove it. We're just gonna plot one measurement. So now that's looking better. Let's see the time axis. So let's plot 20 seconds and increments of 1 second. Okay, and that's it. So now for the trend, we need to add the variable that we want to plot. So this variable will be analog measurement. We are going to make the color blue, purple, I don't know what that color is, and the source, we need to specify which value we want to plot. So for example, we can go to normalized analog input, which we already know is between 0 and 1. And we're gonna update this value every 1 second. Okay, that's it. So let's download this into the HMI. And we should be ready to use our two screens. Alright guys, so as you can see now we have created this button. If we press it, we will jump to second screen, and this is a plot of this measurement that we have here. So we make it 0. It will move down with a refresh rate of 1 second. Supposed to be 1 second, but it looks a bit slow. But anyways, and if we move it to maximum value, it will be a value close to 1. If we press home, we'll go to the main window again. And that's it. That's the tutorial for today.